Hong Kong Institute for Advanced Study aims to be a place of specialized research as well as a platform that provides an open environment for intellectual exchanges across disciplinary fields. It invites as senior fellows and visiting fellows internationally recognized leaders who do their research and teach in areas not always covered by the regular syllabus of the various departments of the university. Those fellows work in a wide spectrum of disciplines, including mathematics, physics, chemistry, material sciences and biology, both in their fundamental and applied aspects. I am coming from an institution that shares the Hong Kong Institute for Advanced Study values, the Collège de France in Paris. The college was founded in 1530. It carries forward the spiritual and intellectual values of the Renaissance and of the Enlightenment, the same values which are supported by the Princeton Institute and the other institutions following its model throughout the world. The Hong Kong Institute for Advanced Study, or CTU, has its place in this consortium of excellence. The Collège de France Latin motto is Docet Omnia, which means it teaches everything. During my teen years, I was greatly excited by the race to the moon, and I was thrilled to make simple calculations about the orbits of satellites, the escape velocity of rockets. I was amazed by the fact that physics obeyed to mathematical laws, and I decided I wanted to apply my mathematical skills to study astronomy and astrophysics. I naturally went after high school into a preparatory school training students for the contest examination to the French Grandes Écoles, École Normale and École Polytechnique. I was admitted to both schools and chose École Normale, which was then more oriented towards basic science. I was there exposed to modern science, relativity, quantum physics, topics which were taught by charismatic teachers, among whom Alfred Kastler, Pierre-Gilles de Gennes and Claude Cohen-Tanucci, who were all three going to receive a Nobel Prize. Cohen-Tanucci, who was a young, enthusiastic professor, welcomed me in his research group and gave me an optical pumping project for my PhD thesis. As soon as I started working on it, I have been fascinated by the counterintuitive quantum properties of atoms and photons, and this fascination has never gone away. With my research team, I developed a new domain of quantum optics called cavity quantum electrodynamics. It explores the behavior of single atoms interacting with a field containing a few photons stored in a cavity. A cavity is a kind of box for light whose walls are highly reflecting mirrors. These experiments demonstrated the possibility to use atoms and photons to process information by exploiting the strange and non-intuitive features of quantum physics, such as state superposition and quantum entanglement. State superpositions mean that an atom can be at the same time in states having different energies, and that a photon can have at the same time different frequencies and different polarizations. Entanglement means that an atom and a field in a cavity, even if they are separated by large distances, can influence each other in ways which cannot be explained by classical physics. Cavity QED has allowed us to study in detail these counterintuitive features by doing conceptually simple but technologically challenging experiments. Cavity QED belongs today to the very active field of quantum information science. The hope is to invent devices able to compute, to communicate, or to perform measurements which, by exploiting state superposition and entanglement, would be able to achieve tasks that classical devices cannot do. These hold promises for future technological developments which, as most inventions, could benefit humanity. Time and trust are indeed essential in basic science. The most precious resource that universities should give to scientists, especially to young scientists, is time. Time is also a big factor when considering the transition between basic science and applications. It takes often decades between a fundamental discovery and its translation into a practical invention. This implies trust. Giving breathing time to researchers is very important. The funding agencies and the taxpayers who finance them should be aware of the time scale of science, which requires a continuous support. The Nobel Prize of Medicine is a perfect illustration of what I just said about time and trust. It has been awarded to two researchers who have made during 2 decades fundamental studies about messenger RNA, trying relentlessly to modify it to make it accepted without rejection by human cells. This basic science project has paved the way, 20 years after it had started, to the production of vaccines against COVID of much higher quality than the one based on previous technologies. And these vaccines, developed within 1 year after the COVID virus has been identified, saved millions of lives. The institutions whose scientists are the most successful in basic science are those which find the right balance between time and trust, the one which appoint young researchers, trusting in their future and giving them a startup funding, allowing them to build up their research project over several years before having to apply for grants. In science, the transmission of knowledge and expertise from one generation to the next, and within a generation from one place to the other, is essential. The transmission of values, of a spirit and a mindset favoring the free exchange of ideas, the emulation between co-workers who respect each other is also very important. To be able to share knowledge with colleagues who, coming from different backgrounds and cultural environments, have the same values is a privilege of the life of a scientist. This global scientific community is a fertile ground on which knowledge is growing. It should be preserved in spite of all the problems and geopolitical barriers that the world experiences today.